Hello guys, welcome to my channel. In this video, we are going to perform the fineness test of cement. We will discuss why and how fineness test of cement is performed and what is its importance and significance and what is the standard procedure for this test. Okay, we will use this formula, that is fineness of cement is equal to weight of retained cement divided by total weight of cement sample. We will discuss this procedure for the fineness test of cement in the context of IS Indian Standard 4031 Part 1 and ACI American Concrete Institute Code 184-94. So let's start our today's topic. First of all, what is significance and use of this test? The fineness of cement affects the rate of hydration, and hydration means chemical reaction between cement and water. Greater fineness increases the surface available for hydration, causing the greater early strength and rapid heat generation, which is called as heat of hydration. Actually, what happens is the reaction time for smaller cement particles is substantially less than that for bigger particles. A cement particle of diameter 1 micrometer will react completely in one day, but the reaction time for particle with a diameter of 10 micrometers is around 1 month. Therefore, this is a drawback to having too many small or tiny particles in cement, and that is it causes the cement to set very quickly, which leaves no time for mixing, handling or laying the cement. Therefore, in order to lengthen the amount of time it takes for cement to cure, cement must be made in a variety of various particle sizes. This property of cement is measured by the test for fineness test, and which we are going to perform in this video. The other thing is this rapid heat generation will result in shrinkage cracks, and fineness of cement is a parameter that affects the hydration rate, early strength, workability and durability of concrete. So that's why the fineness test of cement is very important in civil engineering, and it is conducted before every concrete test or before preparing any concrete. A pile of cement is tested for its fineness. Apparatus and material required is cement and sieve number 170, which is 90 micrometers with pen and lead, as you can see over here, and a nylon brush for the cleaning of the sieve. And this is the sieve number 170 cement sample. You will need a weighing balance and a trowel. Procedure involves weigh 100 grams of cement sample as W1. Okay, this initial weight of the cement is W1. Put the sample of cement on the sieve number 170, which is 90 micrometers, and shake well the sieve by hand. If you shaking by hand, it should be for 15 minutes, or if you are using a sieve shaker, it should be for 4 to 5 minutes, and it's enough for with sieve shaker. Okay, weight the sieve again and find the retained weight as W2. Okay, find the percentage of retained material that
बटन ऑन करो बटन ऑन करो
will show the fineness of cement. For ordinary Portland cement, this value should be 10%. That is, the value of retained material should be 10%, and for rapid hardening cement it should be 5%. As I told you before, as the name indicates, for rapid hardening, if the particles are more fine, the cement will get hard earlier. Okay, so for rapid hardening this value is 5%, which means that 95% will be able to pass through this sieve number. Okay, it's mean that 90% particles are more finer. That's why it is it rapidly harden, and it is for rapid hardening, and for ordinary Portland cement it is 10%. Okay. And precautions: switch off the fans while performing the experiment, properly clean the sieve so that no particle is left behind, and cement should be dry. In our case, to find the fineness of cement, the formula used will be, as you can see over here, weight of retained cement divided by total weight of cement sample. And when we weigh the retained material, that comes out to be 0.170, which means that 17 gram. So by putting the value, the weight of retained cement is 17 gram divided by the initial weight of sample was W1, which was 100 grams, and multiplying it by 100 to get it in percentage, it comes out to be 17%. Okay. And if we 17%, as we discussed, that for good quality cement this value should not in any case be greater than 10%. But in our case, as you can see over here, there are tiny residue particles. Okay, as you can see over here, these are residue particles, as the cement we were using was kept, the cement bag was kept open for a long time. That's why the lumps were formed in between, and this value exceeds 10%. Okay, this value exceeded 10%. So this cement quality is not good, and not you can say is not recommended for use due to these lumps, and the fineness also has increased 10%. Okay, and now if we subtract 100 from 17, we will get 83%. This shows the fineness of cement is 83%, that the particles which made their way through the sieve are 83%. 83% particles are fine, and 17% are the residue. So this type of cement will not be recommended and should not be used for you can say high importance buildings and high importance structures. So that's all for today. In the end, you are requested, if you are new to my channel, please subscribe it, and don't forget to press the bell icon to get civil related videos.